Let's revisit infinite series. Given an infinite series, S is equal to U1 plus U2 plus U3 and so on. Sum of first n terms of S is given by S sub n is equal to the summation as I goes from 1 to n of U sub I. S sub 1 is equal to U1. S sub 2 is equal to U sub 1 plus U sub 2. S sub 3 is equal to U sub 1 plus U sub 2 plus U sub 3. So that the sum of first n terms becomes S sub n is equal to U1 plus U2 plus U3 dot 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 U sub n. S1, S2, S3, Sn are called partial sums of the series. And they form a sequence called the sequence of partial sums. Now, if U sub I is greater than 0 for all I in n, that is natural numbers, then the series is a series of positive terms. If U sub I is less than 0 for all I in natural numbers, then the series is a series of negative terms. If the sequence S sub n oscillates and does not approach a single real number, the series is said to be divergent by oscillation. Summation I is equal to 1 to infinity of U sub I is convergent if the sequence of partial sums is convergent. Summation I is equal to 1 to infinity of U sub I is divergent if the sequence of partial sums does not converge. Now let's look at some examples using this concept. First one, we have S is equal to 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4 and so on. So we have a series. Now the nth term of this series would be U sub n is equal to 1 by n times n plus 1. Now using partial fractions, we can split this into 1 by n minus 1 by n plus 1. In a previous session, I have already shown how this can be done. What happens to U sub 1? U sub 1 is equal to 1 by 1 minus 1 by 1 plus 1. That is 1 minus 1 by 2. U sub 2 will be equal to 1 by 2 minus 1 by 2 plus 1. That is 1 by 2 minus 1 by 3. Similarly, U sub 3 is equal to 1 by 3 minus 1 by 4. And so on. And for the nth term, we would have U sub n is equal to 1 by n minus 1 by n plus 1. S sub n partial sum up to nth term, U1 plus U2 plus U3 dot 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 U sub n. This is a telescopic sum. And we arrive at S sub n equal to 1 minus 1 by n plus 1. How? Look at this. We are adding up all these. So when we are adding up all these, what happens? Minus 1 by 2 plus 1 by 2. Minus 1 by 3 plus 1 by 3. Minus 1 by 4 plus 1 by 4. Remember, there are dot dot dots here. Minus 1 by n plus 1 by n. So what is left out is 1 minus 1 by n plus 1. So that is how we arrive at this partial sum of n terms. We take the limit. So limit as n goes to infinity of S sub n is equal to limit as n goes to infinity of 1 minus 1 by n plus 1. Using algebra of limits, we split this into two limits. Limit as n goes to infinity of 1 minus limit as n goes to infinity of 1 by n plus 1. This is a constant, so it remains 1. Here n is in the denominator. So that means this goes to 0. So we have 1 minus 0, which is equal to 1. So limit as n goes to infinity of s sub n is equal to 1. So limit is finite. That is, the series S converges to 1. Now let's look at the second example. S sub n is equal to 1 cube plus 2 cube plus 3 cube dot 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 n cube. So u sub n is equal to n cube, nth term of the series. We know the formula for the sum of first n cubes of natural numbers. So we apply that here. We get S sub n is equal to n square times n plus 1 square by 4. And we straightforward take the limit. So limit as n goes to infinity of S sub n is equal to, the limit of this is infinity. Hence the sequence of partial sums diverges to plus infinity. And since S sub n sequence is divergent, it implies that the series diverges to plus infinity. Now let's look at the third example. S sub n is equal to 1 minus 1 by 2 plus 1 by 4 minus 1 by 8 plus dot dot dot. Now what would be its nth term? Now here in example 2, we had the nth term given to us. Here it is not given to us. So when it is not given, we have to figure out the nth term. So here u sub n is equal to minus 1 by 2 to the power of n minus 1. So we have a geometric series with the common ratio r is equal to minus 1 by 2 and a, which is the first term, equal to 1. S sub n would be what? We know the formula. That is a times 1 minus r to the power of n by 1 minus r. So we apply that. S sub n is equal to a is 1 times 1 minus r is minus 1 by 2 to the power of n divided by 1 minus half. Now it's just a question of simplifying it. Keep simplifying it till we get 1 minus 1 by 2 to the power of n times 2 by 3. And now we take the limit on both sides. So limit as n goes to infinity of s sub n is equal to limit as n goes to infinity of 1 minus 1 by 2 to the power of n times 2 by 3. Now here, this is, we have already seen. So this goes to 0 when we take the limit minus 1 by 2 to the power of n. So we have limit as n goes to infinity of s sub n is equal to 1 minus 0 times 2 by 3, which is equal to 2 by 3. So the series is convergent to a finite value 2 by 3. So that was infinite series. Now, if you found this session helpful, please do like, share, and subscribe. Questions, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.